So now we will talk about the properties of vector product, right? So in my previous video I talked about the basic introduction to cross product, and I discussed about some special cases. So now I will be discussing about the properties of vector product. So number one property is that it does not follows commutative law. Vector product, like the dot product, always follows commutative property, but the vector product does not follows, is not commutative. So what vector product is not commutative, right? Now what does that mean? This means that when cross A cross B is not equal to B cross A. Why? Like you'll be wondering why. Because in vector we only don't see the magnitude, we see direction too, right? We see the direction too. We can say that mode A multiplied by mode B, here we're talking about only magnitude, is equal to this is now equal. Why? Because here we're talking about only the magnitude, right? So here you can say that the magnitude will remain same, but the direction different. Like one's direction will be upward and the other's direction will be downward side. Direction different. Now let me tell you how. For example, consider a vector over here, moving over here. This is vector A basically, okay? Consider another vector moving towards B, right? So when we cross A cross B, what we will get by the, like in my previous video I talked about the direction of vector C, or direction of the of product of cross, right? So here you will apply right hand rule, right? You will place your palm, when you will place your palm on angle on vector A along vector B, and you curl your fingers towards B, and wherever your thumb is pointing, that will be the direction of vector C. But remember that the angle must be small. You won't be taking this one angle, you will be taking only this small one angle, right? So here the direction is here, the direction is upward. But what if we multiply, if we do cross product of, if you do cross product of B cross A? So you will, first of all, you will place your palm over the B and make sure that you are taking a small angle, not the big one angle. You will place your palm over the B, and you will curl your fingers towards A, and wherever your thumb is pointing, you will place that one side, right? So basically when I'm doing this, my thumb is moving towards the downward side. So when we multiply A, when there's a cross product of A cross B, so the direction is in upward direction, right? There is the upward direction. But when I am multiplying, like there's a cross product of B and A, so the direction is towards the downward side, right? So how we can say that they are equal? So they are not equal, but we can say this thing that A you can say this thing that A cross B is equals to minus B cross A. But if like in vectors, minus is nothing. Minus is not subtraction. This minus does not mean subtraction. It means change in direction. Change in direction. There will be only change in direction. So if like we consider B is over here right now, right? This means that B is over here. This means the B is over here. So when I just I put my palm over the B, so you can see over here that if I put my arm over here and curl my fingers towards A, my thumb is pointing towards the upward side, right? My thumb is pointing towards the upward side, right? So it means that if we are taking angle like the vector B on negative side, then they both are equal, otherwise they are not equal, right? So I hope this concept is clear to you. Now the other property is that it follows distributive law. It follows a distributive law. How, what is our distributive law? It states that A cross B plus C is equal to A cross B plus A cross C, right? So this is the distributive law. Now the cross product of vector, now this is an important point coming over here, that cross product of vector with itself is 0. Now look at this. It means that when A cross A, it is equal to A sine theta, right? It means that two vectors are like this, one is moving like this, one is moving like this. So here the angle is obviously 0, and sine 0 is equal to 0, like I talked about this thing in my previous video. So it means first it is A square sine theta, right? Then it is equal to 0, right? So it was once asked in MCQs that the self product of cross product is equal to what? So the answer there was A square. So this was the answer over there, right? So now let's talk about the cross product of the orthogonal unit vectors. What does that mean, right? So do you know about the orthogonal vectors? And so these are known as the orthogonal vectors, right? So over here you can see this is x-axis and this is known as I cap, right? This is y-axis and it is known as j cap. This is z-axis and it is known as k cap, right? It is known as k cap. So what if we multiply I cap into I cap? So I talked here that when we do self product, cross product of vector with itself, it is equal to 0. So it is pretty obvious it will be equal to 0, right? Over here j j vector, sorry, cross over here, j vector, it will be also equal to 0, right? And here k vector multiplied by k cap vector, it is equal to 0. But what if I say you that I cap cross j cap? So what it will be? So it will be k cap. So let me explain you that how it is coming, right? So you can see I cap cross j cap, it is equal to a b sine theta n cap, right? So you can see that the direction between the I cap and j cap, like what's the angle. So you can see over here that this is I and this is j. This angle is 90 degree, right? So here I cap cross j cap is equal to, and now we know that sine 90, like sine 90 is equals to 1. So ultimately 1 will come here and there is n vector, right? And now you can easily see that what the other vector is left over here. Which vector is left over? No, k is left. So obviously I cross j can't be I or j. This will be something else. So it will be k cap. So I cap cross j cap is equal to k cap. Similarly, you can see that when I cross j cap cross k cap, answer will be I cap. Or when I cross ij, jk, and when I cross k vector cross I vector, the answer will be j vector. So you can simply remember the trick over here: I cap, j cap, k cap. When you're moving here clockwise, the answer will be coming the next one with the positive, right? When you're moving over here clockwise, basically you're moving here clockwise, the answer will be positive. But what if you're moving anti-clockwise? So the answer over here will be negative. Like how? You can see over here that if I'm multiplying k cap multiplied by j cap multiplied by I cap, and I cap multiplied by k cap, so here it will be negative. Here it will be negative. Why? Because here I am moving anti-clockwise. So basically you can say that k cross j is equal to I, but j cap, wait a minute, but k cap cross j cap is equal to minus I, right? What j cap is equal to k cap is equals to positive I, but k cap cross j cap is equals to minus I. So now how it is coming, right? We know that we have learned the commutative property, right? When we were multiplying j cap cross k cap, we know it will be equal to minus k cap cross j cap, right? And k and j is equal to I, so ultimately I cap comes. So this is actually how the I minus I cap is coming over here. We can also see that over here, like I and j are done, j cap cross I cap is equals to minus k cap, right? And you can say that I cap cross k cap is equal to minus Jacob. So you can easily remember this one trick, and you can easily find that in what sense the negative will come and when positive will come. So I hope this is clear to you. So in my next video I will be talking about the determinant method and how to find actually the orthogonal vectors, right?